Hello my dear champions, welcome back to our channel Deeksha Karnataka. Today I'm here to discuss in your Masterstroke, in your PU1 theory revision or the concept revision chapters are permutation and combination alongside with Binomial Theorem. I know your time is very important, so let's get back to the session right away. Let's look at the chapter permutation and combination. So again, one question will come from here as well. If you look at the question, sometimes it gets tricky as well. So we'll try to understand in the simplest way possible. We'll try to focus on the basics of it. We'll not go in to confuse ourselves while learning it. While learning, you should try to keep things very simple. Let things come to you, and when you're practicing the problems, you should go, in the different varieties that is there. So let's try to understand the concepts very plainly, very simple, very simply. But before we start the chapter of permutation and combination, we should know how, what is the way of fundamental ways of picking any numbers or arranging any numbers. Okay, and we have two different ways, and that is. Fundamental principle of counting have two ways. One is based upon addition, one is based upon multiplication. Addition comes when there is nothing common between the two events. Okay, when we have the number of ways are distinct in nature, then if you're looking for addition principle, it says that suppose that these are n1 ways. There are this is actually there are n1 ways for the event e1 to occur. Okay, for event e1 to occur, there's n1 ways. Okay, and for event E2 to occur, there's n2 ways. Okay, for event E1 we have n1 ways, for event E2 we have n2 ways, and these ways are distinct in nature. The number of ways the event E1 or event E2 can occur is given by n1 plus n2. This is your fundamental principle of counting based upon addition principle. Okay, now if you want to go to the multiplication condition, this again changes. If one thing can be done n1 different ways, another thing can be done n2 different ways, then if you're trying to do both the things together, it becomes the product of one with the other, which means n1 into n2 ways. Getting it? Yeah, we'll look at more questions, don't worry about it. Okay, we'll look at more questions of this. Okay, let's look at the permutation definition now. Very simple one. Over here, one thing matters is the arrangement. Okay, so in the case of combinations, we talk about only selections. We don't talk about arrangement. Arrangement doesn't matter over there, but over here, order of arrangement matters. So if you write AB or BA, that becomes two permutations. So AB and BA becomes two permutations. Getting my point? Okay, so the arrangement of a number of things taking some or all at a time. Over here, it always talks about arrangement. Taking some or all at a time is called as permutations. Okay, factorial notation, I think you all know. Basically, when you take product of the natural numbers from 1 all the way till whichever number is given, or all natural numbers, it becomes what? N factorial. So 1 into 2 into 3 into till n number if you're taking, it becomes n factorial. We represent it like this or this, your choice, n factorial or this one. Commonly we use this one only. And one more thing, very important note, 0 factorial is nothing but 1, means picking basically 0. How many ways you can pick 0? Okay, or basically how many ways you can pick nothing is called as one way. Okay, that's the combination of 0 factorial equals to 1 set. Let's look at the definition. When we have to look for the arrangement when the objects are distinct in nature, what it means is each of these have individual they are distinct in nature. For example, I can go with this ABC arrangement of this, picking all 3 at a time or picking 2 at a time, whatever it is, picking 1 at a time. So if you want to go with ABC, there are 3 distinct objects. If you want to go with AABC, then again this is a different story, because one of the object is what? Of the same nature. Okay, because we have 2 of these and B and C are separate. We have 3 different elements, but number of letters are 4 over here. Okay, number of letters are 4 over here, 2 being repeated. Okay, we'll see the questions like that when it comes, but right now let's focus on this concept. So when you have the objects distinct, then the condition or total number of permutations or arrangement, permutation means arrangement of n distinct objects taking r at a time. I can take 1, 2, whatever it is, r at a time, starting from 1 to n, of course. Then this is given by npr. I'll repeat again. Total number of permutations or arrangement taking out of n, taking r at a time, is given by npr, and the result for that is given by n factorial upon n minus r factorial. Okay, again, number of permutations of n object taken r at a time is the total number of arrangements. As I mentioned, total number of arrangements of n object in groups of r. Okay, if I want to take 2 at a time, what happens over here, sir? 2 at a time, I can take AB, I can take BC, okay, I can take AC. Do we have any other way, sir? If I'm talking about, let's say, the letters ABC, do we have any other way? Think about it. Do we have another way? I don't have. And if you want to find this value, 3P2, Out of 3, I'm picking 2 at a time. What it becomes? 3 factorial upon 3 minus 2 factorial. That's going to be 1 factorial. How much this is? 1 second. Yeah, 3 minus 2. It becomes 6, no? So AB, yeah. So we have 6. Very good. Very, very good question. So I made a mistake over here. I wanted to highlight this. So AB, BC, AC is there, sir. How many elements are over here? Only 3. But sir, this 3P2 value is coming as 6. Where's the other 3? Over here. I can write AB as BA, BC as CB, and AC as CA. So what we went with right now was the logical understanding, which is choosing the numbers. Yes, the word was choosing. When I chose 2 at a time, I got AB, BC, CA. Please understand this. If I choose, I got only 3 combinations, AB, BC, and CA. But if I look at the arrangements, then we have 3 more. Then we have AB and BA. Then we had BC and CA. Then we had, CB actually. BC and CB. When we had CA, I had AC also. Because in the case of permutation, order matters, sir. So AB and BA are 2 different permutations, but they are the same combination. This first one represents your combinations, and this represents your permutations. I hope this is clear. If you just choose the select option without being worried about the arrangement, that becomes combination, so AB, BC, CA. But if you choose the combinations of course, and alongside the arrangement also, so AB and BA are 2 different permutations, because arrangement matters, sir. The order of arrangement is very important. That's why 3P2 value is coming as 6, but 3C2 value will come as, how much is it? 3C2 value will come as 3 only, sir. If you want to find, this will be, sir, 3C2, and this is, sir, 3P2. This is the best example that I can take to make you explain the difference between combination and permutation. Out of 3 numbers A, B, C, if I choose set of 2 at a time, I get 3 combinations. If I try to look for the number of ways you can arrange 2 at a time, there is 6 combinations. I hope this is the best way to explain the combinations and permutations and the difference between them. I hope it is clear now. Please have a look, okay? Yeah. Now, when the objects are not distinct, when you have repetitions, for example, in the previous one we had A, B, C. When you have that, you got to divide by the number of repetitions, okay? Let's say A1 is coming, an object of first kind is coming, A1 times or A2 times, like that. Let's say I have A coming at 2 times, so I'm going to go like that, okay? Change it. So we'll have 4 factorial divided by, what is that? 2 factorial, okay, because A is coming 2 times, like that. So this is going to be 4 factorial, because how many terms are there? Total 4 terms are there, A, B, C. So we're going to divide 4 factorial divided by 2 factorial. Answer will become, how much is it? 24 by 2, 12, okay. In general, if A1, AI object is, again, this is the same expansion of this. If you have I objects, if you go A1, A2, A3, all the way till AR, divided by A1 factorial, each of the numbers factorial. Okay, we have only over here 2. This is taken up to R numbers. Don't worry about this, very simple. Basically, this example will help you understand this. Okay, I'll go to the example. I'll show you right now. Let's have the clarity. Yeah, this example. Check this out. In Allahabad, how many numbers are there? We have 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have total of 9 factorials. Okay, divide by, check this out. You have A coming 1, 2, 3, 4 times. So one kind is coming 4 times, so 4 factorial. Another kind L is coming 2 times, so 2 factorial. Over here, we don't have distinct elements all the time. We have some repetitions also. In that case, answer becomes 9 factorial by 4 into 2 factorial. If you want to solve it, 9 into 8 into 7 into 6 into 5 into 4 factorial divided by 4 factorial into 2 factorial. Am I right? 9, 8, 7, 6, 5. This cancels, sir. And this becomes, sir, check this out. This becomes, sir, 4. 2 4s are 8. 5 into 2 is 10, sir. Now multiply this. 9, 7, 6. 9, 7, 6 into 10. Okay? Yeah, 7 6 are 48, 42 into, you can do this, 9 7 is 63 into 6, your choice. Answer should come as 7560. Okay, just wanted to explain you when the case of repetition is there, this is how it works out. I hope it makes sense. Moving on, let's get back to the combination at hand. Combination is what? Already explained it to you. Combination, first of all, is the way of choosing it, the way of selecting it. We don't go, I'm going to say this again, if I have ABC, we have only 3 combinations possible, AB, BC and CA. And the formula for this is given by NCR, and NCR is given by, sir, n factorial divided by r factorial into n minus r factorial. What is NCR given by? N factorial divided by r factorial into n minus r factorial. So if you apply this condition over here, you get 3C2, 3 factorial divided by 2 factorial into 3 minus 2 factorial. You get here 3 factorial by 2 factorial. Answer becomes just 3 combinations. In this case, the order of arrangement does not matter. Irrespective of the arrangement is called as combinations. I hope it makes sense to all of you. Please check. The number of ways of selecting 0 or more things at a time. Okay, 0 or more. So 0, 1, 2, like that. If you go on this, NC0, NC1, NC2, all till NCN. This comes from Binomial Theorem, 2 power n. Yeah. Order of selecting either R or more. At least R means what? Either R or more. Yeah. At least of R means R or more. So I can choose R, R plus 1, all the way till n. All the way till n. This is your choosing at least R and more. This is what? At most R. Means I'll start from 0 actually and go all the way till R only. At most means maximum of R. From where? From the 0. So 0, 1, 2, 3. All the way till R. So choosing that is called as number of way of choosing at most R, number of way of choosing at least R, number of way of choosing basically a minimum of 0 elements to the n elements. Getting it? Some important properties. I'll show you one question based upon one of the properties over here. I think this one. Yeah. So NC0 is always 1, sir. How can you do that? Find it. Use the formula. NCR is given by n factorial upon r factorial n minus r factorial. So all this property can be proved using this particular expansion or understanding of NCR. Okay, 1 second. Yeah, NCR. Again, NC0 equals to 1, NCN equals to also 1. NCR equals to n of Cn minus r. So basically this sum should be equal to n. So n minus r plus r is equals to how much? N. Okay, if that is the case, then NCR and NCN minus r is always equal. Again, check here, NCR minus 1 plus NCR equals to n plus 1 CR. Okay, again, NCR and NC is given equal. It means that either R and S are equal. From here, R and S are equal, okay, or R and S is added up to what? N. This one the case I'm talking about. When you add them, let's say this is your S and this is your R, adding up to N, right? So when you say NCR and NCS is equal, okay, then either from here we can have 2 cases. We can have, let's say 4C2 equals to 4C2, okay. We can have this case, or we can have 5C2 equals to 5C3, because 2 plus 3 is equal to 5. Here 2 and 2 are equal. Your choice. Getting it? Getting it? So either the n r plus s is equal to n, or r and s are equal. NCR equals to n minus r plus 1 upon r n times of r minus 1. Okay, please go ahead. NCR again, these are expansions. Okay, over here the most useful ones are 1, 2, 3, 4, where the questions will actually come, and over here also this is the relation of what? Combination and permutation. How can I say that, sir? Please check. Please check. If I write this NCR term again, let me erase this. Okay, check over here. NCR is given by n factorial upon r factorial into n minus r factorial. This is NCR, sir. What is this? I can write 1 upon r factorial separately. I'll get, what is this going to be? N factorial upon n minus r factorial. And this value is nothing but 1 by r factorial. 1 second. I can move on this side actually. I can move this over here. We get r factorial times of NCR. And what is this? NPR. So r factorial times of NCR is given by NPR. Gets it? Yeah. So questions now. First one is already done. Let's move on to question number 2. 4 prizes are to be distributed among 6 persons. Okay. All right, 6 persons. So for each person, I have 4 prizes, sir. Prize 1, prize 2, prize 3, prize 4. Okay. The number of ways in which this can be done, if there is no restriction, means prize 1, prize number 1 can be given to what? How many persons? 6 persons. There is no restriction. I can give the first prize to any of the 6 persons. So for giving the prize 1, I have how many options? For giving the first prize, how many options? 6 options. There is no bias. For giving the second prize, I have again 6 options. Because they're saying that no restriction. So 6, 6 and 6. Means all the 4 prizes can be given in 6 different ways. Answer becomes what? 6 power 4. C. Please check. Make sense? Moving on. A crocodile is known to have not more than 68 teeth. Total number of crocodiles with different set of teeth. So I can have a case where a crocodile has no teeth, crocodile has 1 teeth, 2 teeth all the way till crocodile has all the teeth. What is this condition? This is a condition that comes from over here, this result. 0 or more, the first one. Yeah, 0 or more. Okay. So 0 all the way till n. And if you remember, this result is given by what, sir? 2 power 68. So 2 power 4 into 17. 2 power 4, 17, 16 power 17. Yeah. Option is C. Because I can have a crocodile with no teeth. I can have this all the way till. Okay, of course, it depends upon what condition is. If there doesn't have any teeth, he can't eat anything. He'll die soon. But let's not got into the specific of biology. Let's look into mathematics side only. So I can have a crocodile with 0 teeth all the way till all the teeth. Okay. So that is there. Answer is 2 power 4 power 17. That becomes 16 power 17. Option C is correct. Now, last question. A very important one. Have a look. If I have n minus 1 C3 plus n minus 1 C4 greater than NC3. We have a property for this. The property becomes NC4 greater than NC3. How come, sir? When did you teach this? Think about it. N minus 1, basically I'll show you one more thing over here. This is the combination. N minus 1 C3 plus N minus 1 C4. This is equal and this is 1 less than this. Please check carefully. These two are equal. To choose from is equal and the number of choosings are 1 less over here, 3 and 4. Now look at this property over here. To choose from is equal. So this is also n, this is also n, and this is 1 less, this is 4 and this is 3. Please check, this is 3 and this is 4. This is 2 is both n minus 1 and n minus 1. What is the answer becomes? You're going to add 1 to this. So in this condition, if I remove on this side what I wrote, let me just remove this. Okay, 1 second. Yeah. Just look at this. I can write this in the form of n minus 1. I'm replacing n as n minus 1. N minus 1 C3. Replacing I minus 1 as 3 plus n minus 1 C4. Okay. Then what is my right hand side? Right hand side is, sir, n plus 1. So basically this becomes n minus 1 plus 1 C, and this is going to be r. R is what, sir? Over here 4. So my answer comes as, this is cancelled, NC4. NC4. That's what I wrote over there. Please check. Yeah, NC4. Now you can solve this. N factorial upon 4 factorial into n minus 4 factorial. Okay. And over here greater than equal to n factorial upon, what is this, sir? Excuse me, this is going to be 3 factorial into n minus 3 factorial. Check carefully. These two are cancelled because they are both n factorial. And which is more, sir? This is more or this is more? This is more because we have n minus 3 over there. We have n minus 4 over here. If you want, I can write it again. Don't worry. I can write it again. Check this out. I'm getting over here 1 by 4 factorial. Okay, and this is n minus 4 factorial. 1 second, I can do better. 1 second. Yes, just a second. check here. I have 1 upon 4 factorial. No, I can write this as 4 into 3 factorial, and this is as it is n minus 4 factorial greater than, other side, have a look, we have 3 factorial into, we can write this as n minus 3 into n minus 4 factorial, right now, n minus 3 into n minus 4 factorial. So this and this cancels, their positive values only, and this also cancels. So what I'm left with, 1 by 4 greater than 1 upon n minus 3. On this side if you move, so n minus 3 is more than 4, so n is more than 7. Answer is n is more than 7. Option C is the right choice. Option C is the right choice. Please check. Okay, done? Yes. Fourth is option C. Let us learn and revise our chapter binomial theorem now. Okay, if you are able to understand the question that comes in examination, these questions of this particular chapter are relatively very easy, because the simple set of patterns. Okay, if you can identify the pattern in the question, whether a change in sign is involved, or whether it is the sequence of adding the combinations together, then the question becomes relatively easier. Let's look at all of that one by one. Okay, so if you talk about some special cases, so we have seen already all of these. If you remember, we have seen this, sir. We have seen this, sir. We have not seen it, but we know that we can find it. Okay, we know that we can find this. Okay, basically taking the square, then taking the square once again, because we know that we know the formula of taking 3 terms a square also. A plus b plus c square is given by a square, b square, c square, twice of ab plus bc plus ca. Okay, so we know how to find this result also, this as well. These are called as some special case of binomial theorem when we have the powers from 0, 1, 2, 3, 4. Okay, till this point we know how to find it, we know that how to identify this. Okay, but after this, if you have more powers, will you spend more and more time like this? Will you do the power 5 again, power 6, power 10, power 15, power 100? No. Then comes the general expression of using the coefficients of binomial. And how do we write that? Expansion of binomial theorem goes as a plus b the power n is equals to nc0. What is nc0? This is the binomial coefficient when you are trying to choose the when the power of the second term is 0, we try to make this power as 0 and the first power is n. Okay, so nc0 a power n b0, please check. So this becomes nc0 a n, nc1 a power n minus 1 b power 1, it becomes nc1 a power n minus 1 b, nc2. So basically the power of n was here, power of a was here n, power of b was here 0. Every term, what happens? The power of a reduces by 1 and power of b increases by 1. A n minus 1 b1, a n minus 2 b2. Okay, and understand one more very clear thing. If you add the powers of a and b, if you add these, you'll get back to what? Always n. Here also n minus 1 plus 1, this result is also, if you add them, equal to n. Everywhere you check, again n. Okay, even at the last term, check here, this will also become what? Over here, n minus n plus n, it becomes equals to again n only. So if you add the powers of the bases a and b, the result will be always n. Okay, so this is the expansion of binomial theorem, binomial term a plus b power n. Okay, when we have two terms a and b and the power is n. Okay, now what is nc0, nc1? These are called the coefficient of the expansion for the first term, second term, all the way till nth plus 1 term. In the case of binomial theorem, we have total how many terms, sir? We have total of n plus 1 terms. What does n represents? The power that you can see. Okay, if you have power 12, you have 13 terms involved. If you have 15 power, it means the total term will be 16. How can I say that, sir? Think about it. Start here 1, 2, 3, all the way till we have n, but we have also nc0. It means one extra term will be there, that makes it to be n plus 1 term. So 12 it was there, so 13 terms, power is 15, 16 terms, and so on. Okay, how to find NCR? The combination result simply n factorial by r factorial into n minus r factorial. Okay, that's how you find NCR. Basically nc0, nc1 same. Okay, don't worry about that, I'll talk about that in combinations later. Okay, now in this expansion, I can, basically few notes are there that I already explained it to you, but I'm going to read it out once more time to give you summary of all of that. If you have the power of a plus b n, okay, then this can be written as a summary or basically sum of. So either you can write this whole expansion, okay, this whole expansion, or you can remove the expansion and simply write the summation. Means with sigma you can write that from r starting from 0 to n, and NCR represents your coefficient, a power n minus r represents your the powers of the integral powers of a, and b power r represents your integral powers of the term b taken as product of course. As I mentioned, total number of terms in this kind of expansion is 1 more than the exponent n. Then in each term the sum of indices of a and b, means the powers of a and b is always equal to n. In each term the sum of the powers of a and b, if you take sum, it becomes n. Already explained it to you. In successive terms, the index of A decreases by 1 and index of B increases by 1. Okay. Next, the coefficient of NC0, NC1, NC2, NCn is the expansion of this. In the expansion of this is called as binomial coefficient, and can also be written as, so we can write NC0 as C0, NC1 as C1, NC2 as C2, and so on, NCn as Cn. Okay. So we don't have to write NC0, NC1 all the time. We can represent NC0 as simply C0 or C0. Clear? Okay? Yes. Next, some special cases. When you replace, first case is very important one and very commonly used one. Instead of having a plus b, if you have a minus b involved, how do we get that? In the same expansion of a plus b, we have the expansion of this, we just saw, replace this value b with minus b. Then it becomes a minus b the power n. Check here, wherever we had b, it becomes minus b. So depending upon the nature of the power or the index, it turns out to be the positive or negative term. Here power is 0, it becomes basically 1. Power is 1, which is odd, it will be a negative term. So NC1 term is negative. Power is 2, even term, it becomes again positive. So depending upon the power of the term b, okay, or minus b actually, if it is odd power, so all the odd terms, okay, odd occurring term will be negative in nature. So first term, third term, fifth term, seventh term will be negative in nature. That's what it says. The sign of plus and minus appear alternatively or alternately in the binomial expansion of a minus b power n. Okay, a minus b power n. All right. I hope this is clear. This is so this is not clear actually. I can write it again. A minus b power n. So alternatively you have plus and minus sign. Taking a as 1 and b as x in the expansion, we get a plus b as simply 1 minus x and rest remains same. Okay, very common expansion. NC0 plus NC1, basically C0, C1x, C2x square, C3x square, Cn x power n is the expansion of this. We can write this now, C0, C1x, C2x square, C3x cube, Cn x power n. Because the first term is 1, so whatever the power you take for 1, it will always be 1 only, and x will start from 0 here, 1, 2, 3, all the way till n. Okay, now if you take, now from the result of expansions, we are going to the result which is used in examination based upon the coefficients, because they ask us to find the coefficient of this term, like that. So that's why we have to understand how to deal with the coefficient also. So for that, if you take a value as 1, what was it? And b value as x, so we get the expansion again, 1 minus x power n. As I mentioned, odd terms will be negative, sir. Here also, because the power of x, when it is going to be negative, okay, you will have the power, odd, the terms will be negative in nature. Okay, now if you are looking to find this value c0, c1, c2, what is this, sir? So if in the expansion of 1 plus x, I already took that now over here. 1 second, let me erase this first of all and get back to the previous slide. Check here, if in the expansion of this, if I take 1 plus x, this is the expansion of 1 plus x power n, right? So in this, if you take x as 1, what happens? It becomes this side 2 power n, sir. And if you're taking x as 1, this first term becomes c0, second term becomes c1, c2, all the way till cn. So if you add all the coefficient of binomial expansion, the result is always, listen to me, if you add the coefficient of binomial expansion, the result is always equal to 2 power n. N represents the number of, basically the power of the binomial expansion. Is it clear? Yeah, same thing is written over here. Got it? Now for this result, what are you going to do? In the same expansion that you have, 1 plus x power n, remember we have this expansion, the substitute to get this result, substitute the value of this as 0. Okay, actually, yeah, do one thing. In this case, what we had, c1, c1x, c2x square, c3x cube, cn xn, then substitute the x value over here as -1. When you do that, this becomes 0, and this becomes c0 minus c1 plus c2 minus c3, and so on till cn. Okay, what I've done, in the expansion of 1 plus x power n, simply take x value as -1. So odd terms become negative. Now if you basically add this one, this is my equation number 1 and equation number 2. Please check carefully. You'll have even terms coming 2 times. c0 plus c0, 2c0. c1 and c1 will cancel. c2 plus c2, 2 times. So basically you'll get what? If you add 1 plus 2, if you add the equation 1 plus 2, you'll get twice of c0 plus c2 plus c4, and let's say like this cn. Okay, then this value becomes what, sir? 2 power n, because we have this side as 2 power n and this side as, please check, 0. If you add 2 power n plus 0, 2 power n only. Now move this 2 on that side, this 2 on this side, this result becomes c0 plus c1, sorry, c2 plus c4, all the way like this. It becomes 2 power n by 2, and this is nothing but 2 power n minus 1. 2 power n minus 1. Now this is the result it was talking about. c0, c2, c4. If you add the even terms, 2 power n minus 1 is the result. How about odd terms, sir? To get the odd term result, just do this 1 minus 2. Here it was 1 plus 2, you got even terms. If you subtract them, 1 minus 2, then c0 and c0 cancels. It becomes c1 minus of minus c1, 2c1. c2 also cancels, c3 minus of minus c3. So basically you're going to have what? Twice of c1, c3, c5, like this. It will be same as 2 power n, and if you if you want, you can just simply take 2 on the other side, and it becomes 2 power n minus 1 again. Same result. So if you add odd places terms or even places terms, sorry, coefficient, the result is always 2 power n minus 1. Okay, and this is clear. c0 plus c1 plus c2 always equal to 2 power n. And number of terms, this is the result. I hope it's clear, guys. Okay, very, very important. Number of terms in the expansion, if you have n or r terms taken inside the expression in the expansion, and n is the power, or basically the index, then number of terms is given by, this is for number of terms, by the way, not the coefficient, number of terms. Okay, this is not expansion, this is the number of terms. This is given by n plus r, means number in the index plus number of terms inside, n plus r minus 1, cr minus 1. n plus r minus 1, cr minus 1. Now if somebody is thinking, sir, you already taught me that if the power is n, take the number of terms as n plus 1, but that is for binomial, means when you have only 2 terms inside. When you have only 2 terms inside the bracket, then the rule is true that number of terms becomes n plus 1. If you have more than 2 terms, then the rule is n plus r minus 1, cr minus 1. Please check, guys. Moving on. Okay. In this case, this is 2 term. What is the number of term going to be? 7 plus 1, which is going to be 8. Answer is, sir, D. Getting it? Okay. Moving on. 1 plus x, ax power n, 1 plus 8x, this is expansion given over here. They are asking us the value of a plus n. Do one thing, find the second term expansion from here. You'll have nc1, right? And you have, you'll have over here 1 power n minus 1 into ax power 1. This is my second term going to be. And this should be equal to what, sir? 8x, because second term is 8x. So right here nc1 is nothing but n, 1 power anything is going to be 1 only, and this is nothing but ax. This is 8x. Compare over here, sir. Na equals to 8. Na equals to 8. Now they are asking sum of the numbers. Tell me, in what way we can factorize 8? We can factorize 8 as 1 into 8 or 8 as 2 into 4. You can factorize 8 as 1 into 8 or 2 into 4. Now check the combination, either 1 into 8 or 2 into 4. Okay, another way you can factorize 8. Any other way you can factorize 8. 1 into 8 and 2 into 4. There's no other way. Okay, so basically now look for, they're asking us sum of the numbers. If this is, let's say, n, this is a, so n plus a can be over here. If you take from here, n plus a becomes 9. Over here, n plus a becomes 6. Look at the option, there is no 9. Okay, so clearly my answer is, sir, 6, which is option C. This is the logic behind the question. Okay, this is the logical approach. The right approach I'm going to give it to you. But right now, understand this. If the product of NA, if you compare the second term of this with this, 8x, you get NA product as 8. If you write the factors of 8, okay, you get 1 into 8 or 2 into 4. Right? So in this case, if you check, 1 into 8 gives me sum as 9 and 2 into 4 gives me sum as 6. 2 plus 4 is 6, 1 plus 8 is 9. We don't have 9 over here, so 6 is the only option. I take the option and move on. Answer is C. Correct. What about, sir, actual method? That I'll tell you. So for the actual method, find the third term. Find the third term. You can get what? NC2, 1 power n minus 2 and ax the whole square should be equal to what? Third term is 24x square. Okay, over here check this out, NC2 is what? N into n minus 1 by 2. What is NC2, sir? N into n minus 1 by 2. How can we do that? Apply NCR condition, you'll get that. Okay, and what about this? It will be 1 only, so we don't have to write that. It becomes a square x square equals to 24x square. Compare, you'll get what? Check this out, you get n square minus n into a square. Okay, and move this 2 on this side, you get 48. I'm not writing x square, okay, I'm just comparing n and a. Check here, you get this value as n square a square minus n a square is 48. But I check one more time, n a square is nothing but n square a square is nothing but n a the whole square, and over here I get n into a equals to 48. What is NA square? N into A. NA value is, sir, 8. So use it over here. You get this value as 8 square minus 8A and 48. Please check. It's a linear equation actually. 8 square is 64. Move 48 on this side, it will become 16. A comes as 2. If A is 2, N has to be 4. Answer becomes again 6. Can you solve it from here? Please check. You get 8A value as 16. A comes out as 2. Please check. A comes out as 2. Move 48 over here, 8 on that side. It will become 8 equals to 64 minus 48. That's 16. So A becomes equals to 2. N becomes equals to 4. That's your answer. That's the other method. This is the trick method. Clear? Okay. So this is your binomial theorem. Alright. Let's do one more question. Number of terms in the expansion of x plus y plus z. As I mentioned, if the number of terms are different, okay, check here. This is 3, sir. In this case, our value is 3. What is the condition for number of terms? N plus r minus 1, c r minus 1. So n value is what? N only. So right here, n plus 3 minus 1, c 3 minus 1 is 2 only. Okay, so right here, n plus 2, c2. What's the answer going to be? N plus 2 factorial divided by 2 factorial into n plus 2 minus 2 factorial. That's the relation, right? Whatever is over here, write that factorial. Whatever is over here, write the factorial and the difference factorial. Check here, this is cancelled. What I get now? Expansion of n plus 2 factorial. So we get here n plus 2 into n plus 1 into n factorial divided by 2 into n factorial. Yes or no? Please check carefully. This is nothing but n factorial. 2 factorial is how much? 2 only. So if you cancel this 2, you get this and this cancelled. You have the result as n plus 2 into n plus 1 divided by 2. Thus answer as option A only, right? Okay. So I hope you enjoyed and learned the chapter Binomial Theorem. This was the questions and all the concepts from the chapter Binomial Theorem, which is going to be important and very useful in the preparation of CET. Okay. So let me know how you feel about this class. Okay. But that is about your Binomial Theorem. All right.